Thank you, and thank you all for coming. So I guess what we're talking about is how we're getting the most out of every student, and that's our aim at SCAS, and that's why hopefully you sent your children here, because you're hoping we do that for you. So we know that students work best when they're working within a zone, what they call the zone of proximal development, and basically it means that zone where they're ready to learn and take on the next bit of information, but it's not too hard that they deem it impossible. And that's the real crucial thing we've got to try and work out where it is. We also know that they work best and achieve results when we're challenging them, and they're working to solve investigations and maths inquiry. And they need to be doing the maths, not just hearing it as a procedure or someone telling them, but they need to actively be engaged. They also need to be making connections with the real world and what's going on around them, and they need to be working cooperatively. To refine and deepen their understanding, and so we're making that a big part of our maths as well. We also know that its best achievement is gained when we encourage them to represent their thinking and their understanding in multiple ways. So we're trying to encourage our students to think broadly and not just believe there's only one way to solve problems. And probably most importantly, we know that students achieve best when they have a positive mindset. And for mathematics, that's something that's becoming a really big thing now, because there's a history in families of people proclaiming that they weren't good at maths. And that's our number one thing we're banning at SCAS. Illusions are great, and you are all brilliant mathematicians as far as your children know, because it's about believing you can. And as soon as we give them cause to believe there's a reason why they might not be so good, they start to believe that language. And at SCAS, we're basically working to try and ensure that we're catering for all what the research is telling us provides optimal learning in maths. How we do that first is we need to teach to where students are at. We need to target their individual needs. We need to know where every one of your children are in their mathematical understanding in all aspects of numeracy. And what that allows us to do is we can identify where there's strengths and where there's weaknesses. And we can also set learning goals for them along the way and support as well. So basically, this is your child, and at the start of last year, when we embarked on trying to track exactly where they're at for numeracy, we started to look at where is your student at and what do they need to know now. So where is your child? And we're doing that with any new student that comes into school. So we have data on every student through kindergarten tier 6. We know exactly where they're at for all aspects of numeracy, and therefore we know what we need to do with them next. So any new students that arrive this year in the school, our aim for the first 4 weeks was to get in and test them and find out exactly where they're at. And we talk a lot about the continuum, so I thought it was a good idea that I introduce it to you. And as your students progress through the school, you'll become very familiar with it, and it's something that's been embraced in lots of schools at this point. And basically what it is a progression of the sequence that students go through in learning mathematics in the different areas. So the first part we look at is their ability to count. And this is their foundation. If you think about maths, you can't add and subtract numbers if you don't know your count. And in our infant school, and especially kindergarten, students can rote count, but they often can't recognise numbers before and after immediately. Things like that. They would need to build a count to get there. And it's something that we're often not aware of. So we might say to a student, 24 take away 6. We're assuming that they can just start at 24 and count back 6 numbers. But in reality, most students that are young don't have that natural progression. And they would actually sit there quietly going 1, 2, 3, 4, 5, 6, 7, 8, all the way till they get to 21 or 24, and then they would count back. Or they would need concrete objects to do that. And so what we're trying to do is identify exactly where they're at and then cater for how do we get them to that next point. So we're moving them through their learning continuums. It's really important, backward counting, I'm going to highlight that to you all now, is something parents can do. Throughout this school and many schools that I've worked in, backward counting is a big issue. So we pretty much need from birth not to teach them how to count forwards because they work that out anyway, but everything needs to be backwards because it's harder and it's not a natural way of thinking. And subtraction, therefore, and division are always harder for students to learn because it's going against what we naturally do. Counting, number identification is something that you're probably already very aware of and students learn quite quickly. But even counting in tens, counting off decade numbers, things like that. And if you hear that language, all that means is starting at any number, 5, and then counting by tens from that. Things like that, that are skills that we believe are quite important for their strategies later on. And even counting in fractions, once they start getting, through to year 1 and onwards, that ability, if they start talking to you about, we're learning about halves, well, that's a really good point to go, could you count by halves? Because what we're teaching them is fractions and numbers as well, and that they do go on a progression, they're not just a piece of cake or a piece of pizza that gets cut up, which is what some of them believe. And that's the foundation. Something else in the continuum is their numeracy facts. What factual knowledge do they have? Factual knowledge we see as one of the tools to solving mathematical problems. We don't believe it's the only tool, but it's something that helps. It makes it easier for you. It makes you strategize better. And so we actually set factual goals as we go along, and we say, right, if your child's here, this is the next thing they can learn. Factual goals is also something that parents, it's us sitting in class and drilling students on factual knowledge is not going to happen for a long part of their mathematics lessons, because it's something they can do at home, they can do in the car, they can do there's lots of games, online games that drill procedural stuff, and that's really, it's when we say learn it. On that note though, I will add that the old idea of learning our tables that we all did is a progression that doesn't come until students have an understanding. So we're very much about make sure they understand it and can visualise it first, and then they learn it as fact. So there's no point probably saying to them, well, you're in kindergarten now and it's time to start learning your tables, because the reality is they don't understand what groups means yet, and they can't visualise what they're counting, and unless they can do that, the information's useless. And I know my generation, probably older than most of you, that was an issue. We just got told to learn things and we did. The other part we're focusing on is how they strategise. How do our students solve problems? And we're not worried about the answer. We want to know how and why. And that language is coming out in our classes all the time now. So we actually monitor where are they at in their thinking. Can they count on from a number? Because a lot of students can't. And our aim is to become flexible thinkers in maths. So solve problems with different strategies. Algorithms is one strategy, but it's not our only strategy we use. And we actually encourage students to have other ways of solving mathematical problems, because we want them to be able to check and estimate and solve using different means. So that's important. And also, where are they in their place value understanding? Do they understand the role of tens and hundreds and how that works and what 0 does in numbers? And we monitor that as well. Multiplication division, as I said again, it's not more than learning your tables, and it's also about being flexible about tricky ways to solve multiplication problems that we might not have thought of before. We were just told learn them. Now we focus on actually getting out concrete objects and making them get a visual. We then ask them to skip count, having a look at the things that they can see. So if it was counting by twos, we would actually get students from very early on, so from kindergarten, we would be putting objects in and we teach them to whisper count. 1, 2, 3, 4, and you drop the counters in as you're making groups of 2. Our progression from that, once they're really good at whisper counting, is then they can count by twos, because they're starting to just hear the second number. That's why I would say whisper count. So then counting 2, 4, 6. And from that progression, once we feel they've got that, then we can move on to saying, all right, if you can skip count by a number and you understand what it means, now you need to learn your tables. And then you can ask them in any order and things like that. But they've got a strategy, they've got a way of solving it if they don't know it. And they can also look for other ways. If I don't know 7 times 4, well, I could do it as 3 times 4, and 4, sorry, so it was 4, 7, so 3 times 4 and 4 times 4, and then you can add them together that way. So we give them other ways. And fractions and decimals and patterns and algebra is the same. We have a sequence of learning so that we're identifying students in our high school who might not understand the idea of the box, the blank box in number questions. And so really teaching them algebra yet is useless until they understand that that box represents the missing number. So we take them back to where they're at, we fix that problem, and then we move them forward in the progression. And that's the idea of a learning continuum. So what does it mean for your students? It means we know where they're at. It means we can look for strengths and weaknesses in their learning. And these skills or aspects of numeracy all build and relate to one another. So if we understand a student has trouble with subtraction, we would look at their counting as our first indicator of can they count backwards. Because often it's not that they don't understand how to subtract, they just haven't got their count yet. And sometimes bigger numbers, that becomes a problem. 13 is the magic missing number that so many students get subtraction questions wrong because they miss 13. Some students count backwards which we think they're really confident in, but when they get to, so they would go 74, 73, 72, 71, 60, 69, 68, 67. So things like that we listen out for, because they're where they seem like they don't know how to do a skill, but they possibly do. So just little things like that. It also means as teachers we plan our teaching to meet your children's needs. And so that means we have removed the textbooks, because a textbook assumed that every student in the class was at the same level and was working on the same page and the same progression at the same time. And the reality of that is very different. So what we now do is we look at where each students are at within our class, and we cluster them. We group them just for a period of time, and we watch for growth. And so we might have a learning objective for the whole class. The focus might be on answering questions with missing boxes, like with missing digits. So we're all working on the same learning objective, but the number range we do that with would depend on where the students are at. And the groups are very flexible, so it's not like you're there for a term and that's where you stay. It's very much a case of, oh, you got it today, you've had that light bulb moment, and you're now going to go into that group because now you need the next level of learning. And that's very much how the classrooms are operating. It also means we can provide, identify if your students need support, and we can goal set. So hopefully a lot of you have started to see goals coming home in some shape or form, and if you haven't, they certainly will be. What we've done is set for all the students in the school learning goals in maths. So basically we're looking at the continuum and we're saying where they're at. So on this one it was a student who can already rote count to 10, from 10, and identify all the numbers. But it doesn't mean we can say to them what number comes after 4 and they would know that yet. So therefore their learning goal is to flexibly count. And if you hear the word flexibly, that's what it means. Can you do a before and after without having to count all the way in order? And so that becomes their learning goal. In the classroom, they'll be working on things to improve that skill. But we also let you know at home, because it's something at least you're aware of, because we find students learn best when we're all working as a team, home and school, so we're sharing the goals with you. And we're also vocalising them with students, because right from a young age, if they know what the aim is of what they're aiming to get to next, they're more motivated to get there. That's not a guessing game for them as well. And as I said before, we also can identify where we need to provide support. And that's at all ends of our learning continuum. So often we will send home letters saying that your child's been selected to work in a maths support group. That does not mean your child's at the bottom of a grade. We actually support students at all levels. So we might intervene for students who we believe are at risk because they haven't got an area yet and we feel they're behind their cohort. So that's one way we would support students, and we've got programs to keep catching them up and give them extra intervention. We also provide support for students when we're watching the data. We collect our data on students quite regularly as part of our ongoing teaching and learning cycle. And we might look at the data and say, oh, these students are still on the same level and they were there last term and they haven't shown any growth. That would mean two things for us. We would look at the student and we would say, well, we need to provide a bit of extra additional support. But we would also look at whether that's a pattern through the class, because maybe we were using a new strategy in our teaching and we're not getting the growth that we'd expect. And so then as teachers, we can reflect on that and improve that as well. So it's working in lots of ways to make sure we're providing the best opportunities for your students to achieve, for your children to achieve. The other thing we're doing with our support is we're trying to make it short, sharp and focused. Students don't maintain interest or concentration for long periods. So our support that we offer is generally 30-minute sessions. We also don't offer it for an ongoing period because we don't want to provide an artificial scaffold for our students. We actually want to see growth, and then we want to see how they cope back in the classroom. So we intervene and provide support where we think it's needed, targeted on a specific skill or a specific area. We then usually, and we have seen some fantastic growth from the programs we've been operating over the last year, we then put the students back into the classroom with no extra support. So they're generally often not coming out of the classroom. Sometimes they are, sometimes they're not when maths is on. But they just go back to their normal program with no support, and we monitor how they're going with that. And if we deem that they're still not up to where we'd like them to be, we might then offer support another term later for a 5-week period again. So we keep that as an ongoing cycle, but we certainly don't lock a student in and say you're on maths support for the rest of your life. Because for growth mindset, that's not really very nice. And it's also not a reality of where they're at. And within the classroom, teachers are catering for every learning level now. So it's not like we're not catering for them. We also offer support in our top end of our students as well. If a student has been identified as working beyond their stage, cohort or their grade area, we acknowledge that we need to extend them because every student has a right to have equal growth, whether they are here or here in the learning continuum. And so that's as much of a challenge for our teachers as it is for students who are struggling. And we need to make sure we provide those opportunities as well. And so we look at our data and we look at students and where they're at, and we will offer extension group maths investigations or challenging problems where we bring a cluster together that might not normally work together because they're not in the same classroom, but we acknowledge that when we put their like minds together and provide them with a challenging activity, that they will probably gain more from each other, as well as what they're already gaining in the classroom. So it's in addition. And we are open to maths acceleration as well as just enrichment. So we do have 1 or 2 students through the primary school that are working well beyond their grade cohort, and if that's the case, we are open to the fact that sometimes the best way to cater for that student is to move them a grade. And it's not as often, but we do offer it if we need to. We also know from research that students learn best when they're engaged in inquiry and investigation style learning where they are doing. And if you've ever walked past the classrooms during maths periods, maths is now quite noisy. They are not sitting at desks with their piece of paper, often solving problems. They are out in groups discussing, debating. There's probably a study in the higher level of mathematical understanding, the more argumentative and loud they become in their mathematical thinking, because the groups get louder and they argue more as they're trying to prove their point. And that's all wonderful because it's meaning that they're getting deeper understanding. These are some of the investigations that we've been undertaking in the past 12 months with our students. Things like what's the best number, what's the best lolly, what's the best pet. One of you 2 are doing that at the moment as an activity. I know you 3 last year when the Olympics was on, we try and find things that are contextually relevant. So we did a whole lot of investigations about how fast are the records, how far is it when they throw the different things. We planned a timetable. We looked at the times that trains and buses and things were going, and we got the students to plan getting to an event. So things that they're hearing in the news and the media, if we make their maths become related to that, it increases their motivation and engagement, and they see relevance for the skills that we're teaching them. So we're trying to do a lot more of that. For Year 6 and the term 4 of last year, they did a whole term on about paying and the costing and the budgeting for their Year 6 graduation. By the end of it, some of them were wondering why they were going because it was such a big cost and their clothes were going to cost so much, and I think they felt a little bit more respect for the parents and what you're forking out. We also like to make it real-world context, not just inquiries often are that way anyway, but we had a focus of financial literacy focus at term 4 of last year. And so Year 5 planned a big day out. They looked at the costing of their excursions and things like that, and they actually planned an excursion themselves. I know Year 4 wanted a class party, and they actually had to work out how much they should all bring in, and they did the budgeting for it, and they worked out how many pieces of pizza they'd be getting, things like that. And it can change right down to, in kindergarten, there are lots of books that we can relate maths to, that they start solving problems. There's a wonderful book, one is a snail, 10 is a snake. It's about the number of legs on animals and how would you create different numbers, what combinations of animals would you have together to get lots of different numbers. And it encourages flexible thinking because there's no one right answer. And that's what we really want the message to be for our students, that think creatively. When the kindergarten teachers ask them to show 5, they don't just expect students to do this anymore. They've got students trying to show 2 and 1. They've got students, we had a student last year call out, it's 10 halves. So we're getting them to think. There's no one right answer, and that's what we really want encouraging. The other way we know students learn best if they use multiple representations to communicate their thinking. And this is a model we're using right through the school with our problem solving. And it's something we're showing you because it's also a great thing to use at home if they're ever doing any of their maths homework. So basically what we're encouraging students to do, and I will admit in kindergarten they haven't yet been exposed to the idea of rounding numbers, so that's going to be a little bit trickier, but certainly from year 1 on we are. And so we ask them to estimate, but in kindergarten it might just be thinking about the value of numbers. So wherever we give them a problem, whether it's multiplication, division, adding a word, story, anything like that, what do you think when you put those numbers down and look at the operation, whether it's minus or adding, what do you think the answer is going to be around? And for our older students, we encourage them to round the numbers and estimate quickly. And we often say to them, round the numbers, solve it within 20 seconds, quick, it's got to be fast. They now have a ballpark figure of what the answer is going to be around. Then we get them to use 2 different methods to solve their problem. For our older students, one might be an algorithm, one might be drawing the numbers, one might be splitting, drawing unit 10 frames, drawing longs and blocks and things like that, if that's where their mental state is out of what they're thinking about. They might do a tally with a whole lot of ones if they need to, but it's certainly about getting them to communicate how they're solving the problem. One of the strategies we do encourage is counting off the decade, so that if you ask them 73 and 58, that not only do they do an algorithm, but they might start at 73 and count 50 more from that, 83, 93. So that mental computation stuff, so they're starting to think about how they're thinking. And then we aim that they look at both their answers and check them. Are they near their estimation? That's the first indication they're probably right. If they're solving it 2 ways and both get the same answer, well, they're 9 times out of 10 they're right. And that's what we're encouraging them. We're encouraging them to solve it 2 different ways. If you get the same answer, well, you don't need to ask someone. And maths is a lot about that. We don't want them wondering if they're right, we want them knowing they're right. And that builds positive mindset as well. So we're very much about, and for checking, if it's a subtraction, then we teach them to check with doing an addition, add them back up, things like that. So it's just encouraging good mathematical habits and explaining and justifying. A lot of work from the students comes from them justifying, explaining and drawing pictures to show. How do you know? And that's something at home we ask you to do. Ask your children when they come and say, look, I've just solved this. How do you know that's right? Throw it back at them. Often when they're right and you do that, they automatically think they're wrong. But over time, they're starting to learn that no, you're just wanting more information. And it's really good for them because it makes them think. Finally, we know that students learn best when we develop and promote a positive mindset. And that comes from focusing on things that can be changed. We don't want our students to ever think, oh, I'm good at maths or I'm bad at maths. So our language becomes more like, you've worked really hard and look at the positive growth you've gained from that. We're not saying to our students, oh, you're good at maths and that's why you found that easy. So we try not to use terms that label their mind or their thinking, but focus on effort, focus on how much effort they put into things or how hard they're trying. Or that was a really great strategy. Their answer might be wrong. Gee, I love the way you used that strategy. I could see you were thinking about that. Now, how about you try? So our focus is always on you will get there. Everyone has the right to achieve in maths, and that's something we really want to encourage in our students. We are all able to be great mathematicians. We just and there is no one right answer. And mistakes are great because the brain, and there's lots of research, and some of the staff in the school are now doing a course online that's about positive mindset, but the brain is most stimulated when it's working out answers it got wrong. And so we're teaching our students that. There's even videos showing the brain activity and showing students that it's okay to make a mistake. Mistakes are good because it generates discussion. And in our classes, we're promoting that with our students through discussing it together. As parents, basically, we don't want you to spend hours drilling your students to hate mathematics. So basically, we want it to be fun. We want you to bring maths to context. You're probably the people that have most opportunity to make maths real for them outside of the school. We try, but ours is often artificial. We have to bring the outside in or create scenarios. But you're out with them at the shops. You allow them to fill out their lunch orders. All those opportunities, when they're measuring the toothpaste, how many times does it take before the toothpaste is empty? All those opportunities are fantastic mathematical opportunities. And take those and embrace them rather than focusing on the drill procedure stuff that, if someone's not good at adding numbers and you constantly make them do that, all you're reinforcing is that they're bad at adding numbers. There are lovely ways. Get the concrete materials out, make them find it easy. So at home our maths is not meant to be hard, our maths is meant to be easy. It's almost a showcase. Look what I can do, aren't I clever? Rather than, oh, this is hard and you have to help me and we're going to have a battle. So if ever maths is feeling a bit that way, speak to your classroom teachers, because we want it to be a positive mindset and a positive thing. The other thing that you need to make sure is to make it fun. Games, cards are the most vital game for maths and numbers, especially for numeracy, and there are countless games you can play that are great fun. Not that we encourage gambling, but having money as an additional feels two things, because we're doing our cards and we're thinking about the numbers and adding and subtracting, and we're also earning money if we might win or lose, so we can double, which is learning our doubles and things like that. So as long as it's all play and they know there's no context for it, it's certainly great for our maths. So now I hand over to